Alrighty then, we're going to talk about the next problem, power problem. Should be noted that power equals work divided by how fast you can do it. So divided by time. And the unit of power is usually the watt. Alright, so work is, of course, in newtons. If you look at it unit wise, newtons per second, and that is known as a watt. All right, so that's the unit of power. But it's just work over time. If, in short, it's P equals W over T. Super easy to work with. All right, so let's do this problem. So 193 kilogram curtain. Think an auditorium curtain, right? 193 kilogram curtain needs to be raised 7.5 meters at a constant speed in as close to 5 seconds as possible. So think of a stage, ordering someone for a stage ordering a motor to yank this curtain up, and they want it to raise all the way up 7.5 meters as close to 5 seconds as they can get. And you got 3 motors to choose from: a 1 kilowatt motor, a 3.5 kilowatt motor, and a 5.5 kilowatt motor. And you have to figure out which one is the best for the job. So what we should probably do here is list what we have. So we know that we have a mass equal to 193 kilograms, very heavy curtain, a distance that is equal to 7.5 meters, and a time interval to do all this in around 5 seconds. So we want to know, if we do this math, what we're going to do is we're going to figure out how much power will it take to move it in 5 seconds, basically, is what we're going to do. So, I think this problem here revolves around work, because they don't come right out and tell you, hey, this thing is so many joules of work, whatever, but you can figure this out. So what we do know is that power equals work over time, and gravity has something to do with it, because gravity's fighting this motor, right? So if we expand this work out a little bit, we know that work is equal to potential energy. So we can call this mgh over time. And if we know mg and h, which this right here will equal h in our formula, you could call it mgd too. It's just how far it's raised. This would be 193 kilograms times, so this would be power, equals that times 9.81 times 7.5. Of course, this is meters per second squared. This is 7.5 meters. If you do all that math, the top becomes joules, and we want to yank this curtain up in 5 seconds. So move this down just a bit. So power is equal to, after you do all that, it would be now 193 times 9.81 is 1,893, and we're going to multiply that by 7.5, and then we're going to divide all that by 5. So if we do that, it is going to come out to be, so if you multiply the top, divide by 5, you're going to get 2839.99, and that would be watts. Okay. Now these little K's up here, kilowatts, right? These three things mean 1,000, right? So 1 kilowatt is 1,000 watts. 3.5 kilowatts is 3,500 watts, basically. This is what we need. So this is basically 2.839 kilowatts, right? All I did was I just bumped this back 3 decimal places. Let me do that a little bit neater. So I just move this decimal, divided by 1,000, and it comes out to be that. So this is what the power requirement is needed to do the job. So if you went to Home Depot or one of these stores, which one would you get? Well, first you would say, well, I can't get the 1 kilowatt. 1 kilowatt's not going to work. It's just not going to pull the curtain up, certainly not in 5 seconds. The 3.5 kilowatt will pull it up at that speed, but the 5.5 would pull it up and have, no problem whatsoever. So which one do you order? In other words, which motor is best for the job? Well, you got to figure out the cost, right? I mean, a 5.5 kilowatt motor is going to cost a lot more than a 3.5. So I would say the best for the job would be the 3.5 kilowatt, just for the sake of not only speed, but price, right? So I think this is where you're going to get. That's going to be the closest one for the job. The 5.5 would move it way too fast. So, all right, that is it, and you guys all have a good one. Stay safe.